Okay, so this is going to be 113, which is UPC, which is Universal Product Codes. So there's a lot of information at the beginning of this lesson that I'm just going to kind of skip going over just for time standpoint, make sure we understand and know how to do the math more than anything. But essentially what a universal product code is it's what you scan when you buy something at a grocery store. It's a 12-digit code, and that 12-digit code has to follow a certain method to prove if it's valid or not. So there's some codes that are going to be valid, and there's some that aren't going to be valid. And the beginning of this kind of went through and explained it, how part of it is the manufacturer code. So it gave us an example of Dr. Pepper. Then there's a product number, which is a 5-digit number. So each product that company makes would have a different code, and then you have a check digit to essentially ensure that when we go through and talk about this little method right here with these little bullet points, that check digit ensures that the product's going to work out. So there's going to be 12 digits to it, and essentially what you do, if you go through, it says you're going to multiply the first digit by 3, the second by 1, third by 3, and so on. What you do is take your odd placed numbers, and I'm going to kind of go over and make sure we understand the difference between an odd number and an odd place number. But we take our odd place numbers and we multiply those by 3. So we're going to look at this problem together, but that's an example of a universal product code. So all of the odd place numbers, so that'll be 0, that 8, the 0 there, 4, 8, 6, all of those are in an odd position in that product code. They're not all odd numbers, of course, with 8 and 4 being in there, but because they're the 1st, 3rd, 5th, 7th, 9th, all of those are odd numbers, so we would multiply those by 3. Your even place numbers, we just add together, so we don't do anything special for those even placed ones. So the easiest way to do this is have it split up with your odd placed and even place. You're going to go through, get a number, and then we'll add each of those two numbers together. So to prove if we have a valid code is that when we add all of these, when we have our calculation, that number's final digit is 0. And here's our little formula here, but when it means ends in 0, it's a number like this. So 70, 80, 90, 100, 110, so on and so forth. So as long as when we do our calculation and our final number we get ends in a 0, that proves it is a valid number. So I'll go through this problem really quick or slowly to make sure that we understand how these problems work. Because it's one of those, once you understand the concept of it, the problems itself aren't too bad. It's just simple math. But like I said, what we're going to do, we're going to have odd place and even place. So let me get some different colors here to show that. So for our odd placed numbers, we're going to have those there, and then we're going to have our even placed numbers. So the key difference between these two is that with your odd, you multiply it by 3. So like I have right here. Probably should have done that in that other green, but I'm going to add all of those odd place digits up and multiply by 3. With even, I just add across. So when I'm talking about odd, there's that 0 right there. That next digit is going to be an even place. That's going to be a 5. Next digit is the third number in line, which is going to be an odd, which is 8. Fourth digit in line, 4 being an even number, is 2. And we can kind of see what's going on here. I'm basically just rotating through. That 5th place digit is a 0, so that's going to go there. 6th place digit is also a 0. My 7th place digit is a 4. The next placed digit for me is an 8, and that happens to be the 8th in line. 9th number in line there is also an 8. So then next is a 2. The last even place digit is that 6 right there. We're going to close our parentheses. And then last but not least, that 5 is the 12th number in line. That's going to be an even place. So we kind of just rotate those back and forth from even to odd. From there, you can plug all of that into your calculator. So when you plug in your even placed, you're going to get 3 times whatever that number is in the parentheses, which is going to be 78. when we go and do all of our even placed, we're going to get 22. So last step between these two numbers, we're going to add those together. So I'm going to go 78 plus 22, and when I add those together, I get 100. And if you remember what my goal is for that final digit to end in a 0, and if we check right there, that 100 does the job. So this is what is a typical problem. There's really two types of problems. You can have one like this to prove if it's valid or invalid, and we're going to look at another one here in a second. But this right here is a typical problem to prove if it's going to be valid or not. Okay, so for number 2, it tells us that this is an invalid number. So I want you to try this problem on your own, so pause the video and try it. So you're going to split your even and odd up. Go through the same process I just did in number 1, except this time it's going to be invalid. So it's not going to work out this time, but we still need to show the math and prove that it doesn't work. So go ahead and pause this video and try this one on your own. Okay, so here's the math to prove that this is invalid. So if I take the odd place numbers, that being that 0, 2, 0, 4, 8, and that 6 right there, I go through the process of the odds, I get 60. All those other numbers go into the even set, I get 22. When I add 60 and 22, I get 82, which is not valid, which is exactly what I'm looking for. So that's an example of one that doesn't work out. I get a number here of 82 that does not end in 0. So let's talk about number 3. Number 3 says if you make a single digit error when entering this invalid number, can you tell which digit is incorrect? So hypothetically, if you typed in those 12 numbers for your code, you get 82. Do you know exactly which one of these digits you typed in wrong? So that's what it's asking there. And through this process, we can tell if it's invalid, but no, we can't tell. So we can't tell which digit is wrong. Any one of those numbers could have been increased or decreased, and it's something that we couldn't say. So when asked for why or why not, any digit could be increased or decreased. There's not a way for us to tell which number that we did wrong there. The next one's another one I want you to try on your own. It says change one digit, not our check digit, in problem 2 to make this a valid code. So we see that we're off. We should be able to see how much we're off by 2 right there for this being a valid code, or we can go up towards 90 if we would want. But it wants us to change one of these digits up here to make it valid. So there's a few options that we have here, so there's not one way that's more correct than the other. I want you to try this one on your own to see if you can figure out which digit you would change. So pause and try that problem on your own. Okay, so I think it should be noted, or something that we should realize, is that if we go through and change a digit, it's going to be easier to change an even, strictly because if we change an even, we don't have to worry about multiplying by a number. If I change any of those odds, I got to worry about the fact that I'm going to be multiplying by 3. So here's some options with those evens that I could change. Just basically taking a number and lowering it down by 2, so 2 to 0, 5 to 3, or 8 to 6 would accomplish that. Or if I wanted to, I could take that 0, bump that up to 8, that gets it up to 90. All right, and then the second type of problem that that you'll see either on a test or on a quiz is one like number 5, where it wants us to determine the check digit to make this a valid code. So this is another one that I would like you to try on your own. We need to see that the check digit's the 12th position, so that's an even spot. So think about what number that you would have to place right there for this code to be a valid code. So I want you to pause and try that on your own to see if you can figure out what it's going to be. All right, so if we go through and do the math here, we have all the odds, so we can add those up and multiply by 3 and get 48, and then with the even, we can add to see what we have, and then figure out what that last one's going to be, last digit's going to be, to get it to end in a number that ends in 0. So if I add everything up, I'm going to get 69 plus our check digit. So I should see that the closest number that ends in a 0 is going to be 70. So to get from 69 to 70, you of course need to add 1. So that's why your check digit here is going to be 1. Last one here is number 6. So it says, suppose you entered a 8 instead of a 9 when recording this number. So where that 9 is, you put an 8 instead, and it says show by example how this method that we've been doing would detect this error. So the first thing we should see that this is in an odd placed position. That's the 11th number in line. So because of that, we're going to have to multiply that by 3. So if I think about it, if I have 3 times 9, that's my correct number. If I type in an 8 instead, the difference between these two is going to be the number 3. And with this method, it ends in numbers that end in 0, so that'd be 70, 80, stuff like that. So if you have a single-digit error there, a difference of 3 isn't going to make it a valid number. So if it's 70 and it's off by 3, it's either going to be 67 or it's going to be 73. So this kind of leads into our next question. Do you think that it will detect all single-digit errors here? Your answer here will be yes. It is going to detect all of our different types of single-digit errors, whether that's in an even or an odd placed position. So that's going to wrap up 113, which is on universal product codes. So with everything being open notes, as long as we understand the process of this, it should be something that's pretty easy to do, but that's going to wrap up this lesson here.